Alright, so hi guys. So in this video, what I want to do is I want to go over this problem. This is verifying trigonometric identities. So again, we're doing these kind of problems. This one, is one that, well, I wanted to do because it does look kind of difficult. Sorry if, like, I don't know why it keeps, it keeps doing that. Anyways, it says simplify the trigonometric expression or trig expression using trigonometric identities. So we're just gonna go ahead and rewrite this. So, have tangent of x. Actually, there we go. I'll just do it that way. So let's see. I'm sorry, hold on guys, give me a second. Okay, sorry about that guys. Now, like I said, we're gonna go over this problem. Let me take this one off. So we have tangent of x over cosecant squared of x plus tangent of x over secant squared of x. So, you want to simplify this. And actually, it's not verifying trig identities, I'm sorry. We're using trig identities to simplify this. So I think, I don't know if I said verify, but it's not verifying. It's just simplifying. So, I want to go ahead and just tell y'all we're going to use the following trigonometric identities. So number one, so trig identities, we will use in this problem. We're gonna use number one. We're gonna use, and I'm not really gonna like name what they are. Like, I am gonna show them to you guys, but I'm not gonna like say what they are, because some of them I forgot what they actually are. But tan of x, we're gonna use tan of x is equal to sine of x over cosine of x. We're also gonna use sine squared of x plus cosine squared of x equals 1. So if y'all wonder, if y'all are curious, that's the Pythagorean identity. And then we're also going to use cosecant squared of x. And I'm going to put this in terms of sine and cosine, or, in terms of sine or cosine. This is really going to be 1 over sine squared x. I know that that is also a Pythagorean identity, but we're not going to use that here. Because it doesn't apply to this problem. I don't think it does. And then I think the last one we're gonna use is going to be secant squared of x equals 1 over cosine squared of x. Now, like I said, these are the ones we're going to use for this problem. Like I said, guys, I don't want to just do the problem and then have y'all wonder where I'm getting all these from. These are some that they kind of already give you. At least I think they do. I know for sure they give you the Pythagorean identity and the tangent one. So here, what we're going to do is we're going to make everything, so you always try to, make everything in terms of sine and cosine, okay? Now, like I said previously, just a minute ago, tangent of x is sine x over cosine x, so you have sine x over cosine x. So I'm just gonna kind of get in here and show y'all. I always like to color code these things so y'all know what part is which. And I know that's gonna be over. It's gonna be over the cosecant squared of x. Remember, that was 1 over sine squared of x. And I believe I wrote it here. Yeah, I wrote it right here. So we're gonna just, again, color code that, so I know that for this one, it's like this, right? And then we're gonna do plus, and then I know again that tangent of x, it's just the same idea. It's sine of x over cosine of x, so you always want to make sure, like, try not to confuse cotangent and tangent. I always like to say cotangent, cosine, sine. That kind of makes me remember, like, what that cotangent is cosine over sine, and that tangent must be sine over cosine. So I'm just putting that out there, guys. And then over, it's going to be over. So again, the tangents obviously are the same thing, right? So we have this going on, and then plus, or over, and then the secant squared of x is 1 over cosine squared. So I'm going to put 1 over cosine squared of x. Now, if y'all are curious again, like I said, I color code a lot, so this is what secant squared of x is. You know, this is this one. Now, here, we want to go ahead and try to use division of fractions. So we want to split this number 2, split into division of 2 fractions and simplify. So I'm writing the steps down, guys. Hopefully y'all can read my handwriting. I like to say it out loud while I write it because my handwriting is really crappy. But anyways, so we're gonna do sine of x over cosine of x. And then, again, give me a second. I'm gonna write this down really quick, this rule, guys. Hold on. Okay, guys, so this is the rule I'm using. Just remember the division of 2 fractions rule. So, I'm just going to erase that. So, as long as we understand that, that's how we're going to do it. Now, this is going to be sine over cosine. So, the top goes like this, and then divided by... So we're kind of splitting this up into a division of 2 fractions, right? Divided by 1 over sine squared of x. There's a reason why I'm not putting the, like, literally doing the product of it and flipping it over, because, yeah, I can't do that in my head. Not always. I don't usually do that. So, and then plus, and then we know that, so again, this goes like this, so that's the first part, you know, and then the other part is going to be plus, and it's going to go sine x over cosine x, and you want to put parentheses, guys, divided by 1 over cosine squared of x. Now, here, again, this part kind of stays the same, and then this part over here is this part. So again, I'm just color coding here, so we can obviously tell that this is what this part is, right? Now let's go ahead and just clean this up. You want to remember that when you're dividing fractions, guys, you're gonna flip. So you're gonna keep it, change it, flip it. So change the division to multiplication and then flip this over, okay? So it's going to be times sine square root of x over 1, okay? Plus, and again, do the same thing, and I'm going to put this in, again, parentheses, leave it in parentheses for now, and then do the same thing. So, just know that, like, that's what we did with that part. We flipped it over, and then the blue part is this part. So always, it's keep it, change it, flip it. And then we have plus sine x over cosine x, and then it's gonna go, so again, this part is this, and then times 1, I'm sorry, it's, excuse me, times cosine squared of x, excuse me. Oh my gosh. Hold on, guys. Okay, so, like I said, this is gonna be this part, right? Now, you wanna be careful with how you simplify so the first part becomes sine, I'm gonna just write it this way. I know that I'm, like, really simplifying this, like, really detailed, guys, but I want to show y'all why, especially for those of you that are not good at your algebra. Obviously the bottom becomes a cosine x times 1, which is cosine. So, and then plus, and then this is gonna go sine of x, cosine squared of x, all over cosine of x. And so, again, the denominator is cosine. Now, here, we're gonna simplify this as, you want to understand, guys, that when you, just like with laws of exponents, when we would do, like, u squared times u is u cubed, right? Because you add them, remember that a to the m times a to the n equals a to the m plus n. So if I apply the laws of exponents to this, I'm just going to say that this is equal to sine cubed of x on the top over cosine of x on the bottom plus sine of x, cosine squared of x. Oh god. Over cosine of x. Now, again, we're gonna bring denominators together. So put it in one fraction because we already have the common denominator. That's because we can just simply say that this is equal to sine cubed of x plus sine x cosine squared of x all over cosine of x. Now this is where you want to use the Pythagorean identity and you want to factor. So this part, guys, so this part right here, you need to factor sine of x out. So factor out sine of x. Okay, so you need to do that. Because if you think about it, they have a sine of x in common. So what I'm going to do is, when I do that, I mean, if you want, if it makes it easier, actually, I'm not going to do it that way, never mind. So if you factor out a sine, take out the sine of x, and multiply, so we have sine of x. To get to sine cubed x, we do sine squared of x, right? Because sine x times sine squared x is sine cubed, plus, and we already have a sine here, so we're just going to multiply cosine squared x. You can verify that this is true if you do distributive property, just to make sure you're factoring it right. Put it all over cosine of x. Now, think about it, guys. A times B over C can be A over C times B, or A times B over C. These are just arithmetic properties. I can grab this and put it as sine of x over cosine of x. And then do the and then remember we had said it at the very beginning, we had said that the sine squared of x plus cosine squared of x was 1. So this, we're gonna put this in here. So this part is equal to 1, right? So we have sine of x over cosine of x times 1, right? Which is going to equal to sine of x over cosine of x. Now remember what I had said at the beginning, what we said at the beginning was that sine of x over cosine of x is tangent. That's why I wrote this. So therefore, this simplifies to tangent of x, and therefore our answer is tangent of x. I really hope that helps, guys. I know that my explanation is extremely lengthy, but I want to explain this in as much detail as I can, because I know like some people really are struggle with their algebra, but you want to make sure you understand your algebra very well. And you must understand how to factor. So if y'all do have trouble with factoring, I can make more videos over those. But if you're not sure if your answer in factoring is right, you can go ahead and verify that it is by doing distributive property. So, with that being said, guys, I really do appreciate you watching. Thank you so much for watching, and thank you for subscribing. And with that being said, please like, comment, and or subscribe. And if anybody has any questions, let me know. And I will see you guys in the next video. Bye, guys.